Hi, in today's video we're going to do a little shop maintenance. This is my Hakko FR400 benchtop desoldering station. I've had this for about 2.5 years, and I've noticed recently that it's not working quite as well as it did when it was brand new, and I think it's time to do a little maintenance on it. Desoldering tools are a primary tool on everybody's workbench because removing components is the step you have to do before you put in new components. So this gets a lot of use. Basically what we have here is the benchtop unit has the controls and the motor and the vacuum pump in it, and then you have the handset here with the trigger to activate it. The heating element is built into the tip here in the handset, and it has two connections between the handset and the benchtop unit. One of them is the control line, so it can heat up the heating element and monitor its temperature, and the trigger activates the pump. And then there's a hollow vacuum tube line, which I think is this one, for the suction, and it feeds into here. This gets a lot of use. In an average week, it's probably in use between 20 and 25 hours, and that's quite a bit. And if you don't take care of it, it won't last, and it was rather expensive. So one of the things I've noticed recently over the last few months is it tends to clog up or lose suction more frequently than it did when it was brand new. Now, any desoldering tool which has a vacuum pump in it, clogging up is a reality of life. The way this works is when this unit is on, it heats up the heating element in the tip, and when you pull the trigger, it activates the motor for the pump in the benchtop unit, and the suction pulls the melted solder into the reservoir here. The FR400 is a good design. It has a lot of subtleties in how it operates, and one of the things I liked about this was it has one of the highest suction ratings for any benchtop unit that's made, and also the way it functions is the motor starts running the pump just a few milliseconds before the valve opens, so you have this reservoir of vacuum in the unit already, so when it opens it, you get this burst of suction to pull the solder off the board, and that seems to work really well. The other thing about this which I liked is the heating element is the entire tip assembly. It's not just down here at the end. The whole thing is part of the heating element, because as the molten solder is drawn into the tip, the units with the heating elements just at the end, as the solder flies back through the tube, it starts to cool down, and sometimes by the time it gets back here to where it lands, it's solidified to a certain extent. This way, with the whole tube being heated, it doesn't tend to cool down as quickly, and it tends to pile up back here in the reservoir better. So there's a lot of things that can go on with this. It's just a fact of life when you have something like this, especially if you use it a lot. There's a certain amount of maintenance you have to do. The most common thing that you have to do is you have to replace the tips. The rosin in the solder, rosin is the flux in solder, it's somewhat corrosive, and it tends to eat away at the opening in the tip and inside the body of the tip. As the surface inside the opening here becomes rough, then the solder tends to pile up and stick to it more. These are the molted microscopic pieces of solder, and when that happens, it tends to clog up more frequently. So tips have to be replaced fairly regularly if you use it a lot. Since these are relatively expensive and you don't want to waste them, what you can do with these as a tip is most of the ones that we use for most components, they have a 1 millimeter opening here at the end. See, 1 millimeter. As they wear and become less efficient to use, you save them, and you can very carefully drill it out with a slightly larger drill bit. They make these in a variety of sizes, anywhere from 0.8 millimeters up to, I think it's 6 millimeter opening is the largest one. And what you can do is you can drill out the hole and make it larger. That way you don't have to buy another one, because you're not really using 3, 4, and 5 millimeter tips that often. So for occasional use, it's just fine, and you save money that way. So tips have to be replaced. The other thing that happens is this is the reservoir that molten solder flies back into, and it has a rubber seal here because you have to preserve the vacuum, and then you can push out the other end and you can see this is the little cup where the solder flies into the cup and it cools down and it sticks and it piles up here, and you can actually break that out with a screwdriver. And then on the back side, this is the first filter assembly, and you can see it's relatively thick and it's made out of some kind of fiberglassy kind of material. It's not just paper or cloth, it's something that has fiberglass in it. And you can see on this side how the little tiny particles of solder and flux that make it past the cup, they pile up on this side and eventually they clog it up, and this has to be replaced. So there's a lot of consumable parts in it. And the other thing that happens is with the molten solder and the flux and everything, the inside part of the tube also becomes rough and irregular, and again it catches the particles of flying solder and they tend to build up in the cup instead of going in the back, so eventually this has to be replaced. That's all kind of normal maintenance that you have to do. And then the other thing is here on the base unit, you can remove this, and there's a secondary filter here, which you can see on the back side is white, but on the front side it's turned somewhat yellow. And this is the second filter. It's connected to the vacuum tube, and it catches anything that gets by the primary filter, and primarily what happens here is it's vaporized flux or rosin that makes it onto this, and this protects the pump that's inside. So these have to be replaced also. One of the things I've noticed recently is in this little cap here where that holds the filter in place, we were having a problem with losing suction, and I noticed that the hole in the center of the cap, right here, this little hole, it was filling up with flux deposits, and it was becoming smaller and smaller and smaller diameter. It was sort of like arteriosclerosis for vacuum pumps. So that was a problem. And the other thing that happens to these is since the residue from the flux builds up in this, it also can fill up in the vacuum tube itself, and then it's just like a bad artery. It closes up and it reduces the volume of the tube, and then the suction doesn't work as well. So there's all kinds of things that have to be done on this. We'll unplug the handset for a second, and if I turn this over, you'll notice here we've got this, and anybody who's ever cleaned out a computer, this will look noticeable to you. We've got all kinds of lint and crud that have built up, and I'm guessing it's inside also. So we're going to take the cover off this and see what it looks like and clean it out, because this was really expensive and it's got to last. So let's go ahead and open this up and see what we get. Go ahead and we'll take the covers or the screws out that I think hold the cover in place. I have not ever opened this one up before, so this will be the first time. I guess the practice is first reason because I tell me to do that all the time, so I have to do that myself. I have a feeling that this is probably going to be really messy inside. Especially if we figure out how to do it. There is a fan on the back of the unit here. So it's pulling air into the case, and I assume the fan is exhausting. Well, the fan is pulling air into the case through the vent holes in the bottom, hence all the crud buildup. Well, it's starting to make it easy. There we go. Oh, it's 2 pieces later. All right. Left-hand side, right-hand side. And here we have the internals of it. And basically what we have here is we have a big primary transformer. There's the motor is down here. The vacuum pump is this assembly. And this, I'm not sure, this is another motor that has to do with the vacuum also. I've never really looked inside one of these before. It's not actually as dirty as I would have thought, but there is a certain amount of fuzz buildup. So let's go ahead and get that cleaned out. So we got the shop vac here. we're going to do this is use a purple flip and you rub it in. So open it up. Let's go ahead and we'll put this back together. Okay, dust that off, and that takes care of that. So we'll put this over here for right now, and get rid of the fuzz here. So another thing we'll do real quick before we're done with this is, we've got all kinds of parts that I ordered. I'm going to replace the front filter cover with a new one. Not that there's necessarily anything wrong with this one, but it will be a good backup or spare, so we'll save that. We're not big on wasting things around here, so I have a tub full of somewhat used but still good parts. We'll put a new secondary filter. So the way this works is you put it in the cover and then you place it here and push it on. When you push it on, it forms a ridge to seal. So that's done. We'll put this out of the way again, and now we're going to work on the handset. So what I want to do with the handset is I'm going to replace the hose that connects the handset to the base unit, and I have a new one here. Parts for these are not inexpensive, but I like buying factory replacement parts. So to do this, we have to remove the heating element from the end of the handset so we can unscrew it and open it up. So there are 3 screws. They're machine screws. And then the tip and heating element unplugs like this. So this is the tip and heating element. So this is the actual heating element here, and then there's another one inside the tube here. This is a fairly pricey piece, so you want to take care of it. It should last a long time, and if it doesn't, you'll have to spend a fair amount of coin to get a new one. So put that aside, and then we'll take the handle apart. Screwdriver. There are 4 screws. They're all machine screws, and it feels like they all go into metal threaded studs. And you take this off. The handle is made out of metal, or no, I guess it's really heavy plastic, but it's got that kind of metal feel to it. And inside, all you have inside here is you've got the wiring loom that comes in from the control unit. There's a switch here, and wires go up to the socket here, which is where the heat element plugs in. And here's our vacuum line here that goes out, and it's connected to this piece up here. But what we're going to do is we're going to remove this piece, and we're going to take the vacuum tube, and it's held onto the control wire assembly with these little round clips. So we'll just unclip it. And this is a good quality material. I think it's probably a silicone based material, because if you accidentally say put your soldering iron on this, it doesn't melt. So we'll be saving that, but we are going to install our new one. It seems as if there's a sleeve on this end for some reason, which is not on the original, I don't think. Nope. So I'm guessing that the sleeve probably goes on the unit end so it doesn't get kinked. So what we'll do is, this is the sliding retractable part for the reservoir that holds the solder. It's got a barbed connection on it. We'll put that on. And we'll set this back in place. And we'll just route this through the clip. It's in the handle. Make sure you have everything lined up properly. And it's probably best to put the handle back together now before we put the tube back into the harness clips. Alright, so that takes care of that. And then we'll clip the vacuum tube back in the clips, trying to make sure we get it all evenly spaced. And that takes care of that. We'll put our heating element back in. Oops, this way. Snaps into place. We'll put our 3 screws back in. The top screw is about twice as long as the 2 side screws, so make sure you get it back in the right spot. 1. There's 2. And there's the 3rd one. So that's done. The next thing we're going to do is I'm going to replace the reservoir assembly with a new one. So you can see how this one, the plastic is translucent. This one is all dark because it's got microscopic bits of solder all built up on the inner surface. So I bought a complete assembly. You get the 2 gaskets, front and back. You even get the filter and the little cup that holds the solder. This is the part the solder flies into, then it gets cold and sticks to it. So the same thing happens on the old one. The surface of the metal cup gets all rough and then it's hard to pop the solder out. So if you can buy just the upper front seal, just the back seal, just the cup, and just the center part. They're all separate pieces that are available, but it makes more sense and it's a little less expensive just to buy the whole thing. So this just sits in here like this, and that's ready to go. And then we're going to put a new tip on it today. The other tip's been in use for a while. I think on an average I probably go through 4 or 5 tips a year. So this just sits on the front like this, and then you slide this down, and they give you this tool that comes with it when you buy the kit, buy the whole setup, to tighten the locking nut, because this all gets hot. This is all like 750 degrees and you can't just unscrew it with your fingers if you have to change the tip out. So you got to keep that stays on the workbench. I'll show you some of the tools you keep out on the workbench all the time when we get this thing fired back up. So let's go ahead and do this. We have to put our suction tube back on here. That should be fine, so we'll do that. We'll plug our handle connection back in. And let me get some power for this and I'll show you how it works. Alright, so we'll go ahead and turn this on. It's got the fan. When the fan runs, it's reasonably noisy, but that's just part of it. When it's back in the cubby over here, it's not as noticeable. It's got a fairly large backlit LCD display that displays the temperature of the heating element. And it doesn't take too long to warm up. It does have an auto standby or sleep mode, so if you don't pull the trigger for a certain amount of time, it will time out and go into sleep mode. And sleep mode drops the temperature of the heating element in the tip from, like, I have it set at 750 degrees usually. I think it drops it down to a little under 300 degrees. That makes the heating element and the tips last longer. So it takes a few seconds to heat up. It's got a fairly simplified control, but there's a lot of options. So there's menus and so forth. One of the features that you can program into it is you can set it up so it works as I have it set up, which is when you pull the trigger it turns on, and when you release the trigger it shuts off. You can set it up so that when you release the trigger the pump runs for a half a second or a second or 2 seconds longer if you want to. That way you make sure that everything evacuates out of the lines before the pump shuts off. I tried that for a while and I found that you don't always want to do that, and it's easier to train yourself to hold the trigger for a half a second longer as you move from joint to joint. It's just a matter of getting used to how it works. So what happens is it's all brand new now, and when the tips come, when they're brand new, and you'll get to see this if we can get it to focus, the end of the tip is solid with solder, but when we turn it on the first time, it sucks the solder out, and now we have our 1 millimeter opening in the end of the tip. So here on the display you can see there's a suction gauge, and as we pull the trigger the bars go up. Let me show you that close up. So down here is the bar graph. There's one segment lit up now, and when you pull the trigger more segments light up. It's measuring the vacuum within the system. So if things start to clog up, if the tip starts to clog up, or the heating tube starts to clog up, or the primary filter in the back of the reservoir starts to clog up, or the secondary filter down here on the unit, there'll be more and more bars that light up. And if you reach a point where there's no airflow at all, it says all of the indicators light up, and it says check because oops, someone's pinched the tube. Okay, and then it goes back down. So one of the things you have to keep an eye on, and you can tell from how it sounds, you can tell that it's not drawing properly. You can also tell because it's not sucking the solder up the way it's really supposed to, but you can tell by the sound also. So one of the other things you have to keep in mind is you have to do periodic maintenance as you're working on the tip and on the heating element assembly and on the reservoir if you use it a lot. And this is where our assortment of tools come in handy. So this is our tool for removing a hot tip from the unit. So we'll unscrew that and slide it out. So here on the end of the heating tube there's a little opening, and that can get clogged up with solder. So they give you this tool, which is the same diameter, and you can turn it on and run this through it to make sure it's clear. And without the tip in place, instead of having 6 segments lit up, we only have 3. And we'll put the tip back on. And then the other thing, which I keep on the bench, they also give you this. This is a 1 millimeter wire probe, and this of course fits in the 1 millimeter opening in the end of the tip, and you can use this to clear out the tip. So what gets stuck in here? Well, most of the time it's just a little bit of solder buildup that gets stuck in there. Also, sometimes when you're desoldering things, you might get a little piece of broken component lead, and it'll make it inside the hole also, and if it gets stuck in place, that's kind of hard to get out. That's why I keep this little pin vise drill bit here. This is 1 millimeter, and you can use this and you put it in the end of the tip and you turn it, and you can usually get the piece out or push it through or something like that. So that's good. And then if you're desoldering a lot of things, you have to periodically empty the little metal cup. And there really isn't much in it right now because we haven't really desoldered anything. But you can see just with the little bit of horsing around that we've done Here's some solder. This is what's been pulled through the different parts of the handle just while I've been making the video. And then it builds up in the cup here. And then when this is brand new, usually you don't have to take this all the way apart. If you just take it out, take the top off, and you turn it upside down and bang it, the piece will fall out and it'll be this chunk of used solder. So if you use it a lot, you have to take care of it, otherwise it won't work as well as it's supposed to. So that's how you take care of your Hakko FR400 after 2.5 years of heavy duty use. So let me show you how great of a tool this is. For those of you who don't do this for a living, you have no idea how important of a tool that it really is. You know, I've been working on electronics since I was in high school, and back in those days all you had was desoldering braid, which we actually still keep on the bench because, as old-fashioned as it really is, here's desoldering braid here, as old-fashioned as this is, this does come in really handy sometimes. After desoldering braid, you had these little handheld vacuum plastic pump things that they were just awful to use, and you have to do it with two hands, one hand for the pump, one hand for the soldering iron, and it's just awkward and really hard to do. You can get by with that pretty well. If you're doing a lot of single-sided through-hole boards, you can get by with all of that pretty well. If you're working on double-sided boards with through-hole parts, you need something much better than that. And so I'm going to give you a practical example today. So this is the Intercom control board out of a NuTone IM4006. This is mid 80s, early 90s vintage, and as you can see, it's just full of all kinds of through-hole parts. You've got all of these ICs and all of these resistor all over the board, and these are relays and so forth. And this is one of the more difficult boards to work on. If you have to remove an IC from this board, it's a difficult task to do because the ICs are connected. There's traces on this side, and then the pins go through the board, and then there's lots of traces on this side of the board, and it's very challenging, and it's very easy to ruin a board by trying to remove a component from it. And I'm going to show you how great a tool like the FR400 is. So just to make it simple, I'm going to remove this one, this IC right here, this one. And here are it's a 16-pin dip package, and so it's this row of legs and this row of legs, and what we need to do is desolder these. So what you have to understand is through-hole board, double-sided through-hole boards, you have traces on this side with solder pads, you have traces on this side with solder pads, and there are connections that go through the holes in the board. So there's like these little tubes of copper that connect traces on this side of the board to traces on this side of the board, and you have to get all of the solder out of the tubes so the legs will simply slide through and the chip comes out. If you don't get all the solder out of the tubes and you try to pry the chip out, you'll rip the tubes out from inside the holes in the board, and then you break the connections in those points from one side to the other side of the board, and it's no good anymore, and that's a real pain to fix. So if you have to replace a lot of ICs, sometimes on this board in particular, if this comes from a unit where the customer has lightning damage, sometimes you have to replace all 8 ICs on this board. So it's 8 ICs times 16 legs, so you do the math, and that's how many chances you have to screw it up. If you do 7 of them perfectly and you screw up the last one, you're going to have to fix it because you've got a lot of time invested into doing this. So you need the proper tools to do this properly. This is not as easy as people think. So I'm going to try to do this so you can watch me do it. You won't be able to see me. I can't zoom in close enough where you see it actually work, I don't think. But let's see how it goes. So we're doing this one right here. So can you see? Probably. Okay, that was our 16 pins, and while I can see the openings through the boards around each pin, the other thing you have to do is you have to look on this side of that IC and make sure that where it was soldered on this side, all of the solder is gone also, and it looks pretty good. And then you very carefully give it a little nudge and if you get really lucky, it just falls out. And that's why the FR400 is so good. Trying to do this with desoldering braid or trying to do this with a handheld vacuum pump, it's just a nightmare to do. This is really the kind of tool you have to do this. So I hope you found this interesting and perhaps helpful. If you did, please give it a big thumbs up on YouTube. Thumbs up, because that always helps. If you like our channel, there'll be a banner right here. Go to our YouTube homepage, click on the bell or on the wheel, put in your email address to subscribe, and every time we post a new video, you'll get a notification and you can watch it. That's all for today. See you on the next video.